Hello! How's it going? Hopefully the sound balance isn't too bad. Hope I don't just break your headphones. Welcome to the Nutshell Maths live tutorial. There's quite a few regulars here. There's also a bunch of new people. There's also heaps of new followers. Shout out to, should I say them? Croco, Dan, Troubleshooter, Kiwi Ninja, The Flat Earth Society, Olivia Olive, Brad the Top Hat Penguin, Rassles, Ko Magoo, and Miss None Your Business. Thanks for the follow, team. Right, this is how things are going to go. Firstly, these are my suggestions on how to operate. If you're new to the channel, make a Twitch account. Twitch is a free service. It doesn't cost me to stream. It doesn't cost you to view. It doesn't cost to make a Twitch account. If you make a Twitch account, you can chat and ask as many questions as you want. I can see them. I can answer them. Last but not least, exclamation survey in the chat to complete the survey. It's just a straight up, nice and easy Google survey for you guys to please do. It gives me feedback, lets me know if I'm doing good or not. Right, other things. Look at this. How to make use of this. Exclamation survey. Oh, it's exclamation form actually. Exclamation form. My bad. Right? Exclamation form and it'll pop up. Sorry. Right, how to make best use of the Nutshell Maths Twitch tutorial. There we go. Now that's worked. Thank you. Thanks for the follow here for the gold. Right, firstly, follow along with me while I do the paper. Okay, exclamation questions, exclamation answers. Right, exclamation questions and exclamation answers. You'll get straight access. It says the form is closed. Oh, no. Let me try fix that now. Oh, whoopsies. That's not right. Let me try fix that. That just aggressively popped up on my screen. Oh, don't worry about the survey for now. I'll sort it out. Yeah, I'll sort that out in a second. Let's get started. Very soon. Right. So we've got follow along with me. Do the question, exclamation questions. That should work. And then ask lots of questions as we go. Right. Most importantly, I am not a replacement for a teacher or what you've learnt so far this year. So if I say things different to your teacher or explain things different, that's fine. Listen to them, not me if it doesn't make much sense. Okay. I've got my orange juice. I've also got water. We're in for a nice treat. We're doing some probability tonight. Level 2 probability. Okay. I've got the test paper. I've got a new setup. If you haven't noticed, it's much nicer. Look at this. Boom. We're doing the NCEA. Look, I can zoom in, zoom out. So much nicer. I went out and bought an iPad so I can do this. Right? So we got apply probability methods. If I'm looking down a lot, it's because I'm writing on my screen just for the new people. Okay, this is what we're doing. It's worth 4 credits. Should take you an hour. It'll take us probably about 2 to go through and explain everything. Ask lots of questions. Give me lots of feedback. And let's get into it. Let's look at question 1. Before we look at it, maybe I will explain something. Let's explain something. This assessment is split into 3 parts. No, this isn't calc. I think it's probability first, then calc. Probability first, then calc. Or is it calc first? Did I say calc on the thing? We can probably just do calc if we want to do calc. Oh, I should check the thing. Let's check my image. I think it is meant to be calc, eh? You might be right. Give me 2 seconds. I've got to find the image. Oh, yeah, it is meant to be calc. So should we do calc? Calc? I've got probability all up and running, but it will take me a couple seconds to get calc sorted. Let me just go like this. Let me just turn this off for a second. I will get the calc one open and we can do calc. Easy peasy. Any order is good. Let's get a quick vote going. Prob or calc. I said I was going to do calc, so I probably should do calc. Right. Vote there. I'll get it open so I can do calc. I prepared more for prob, but I'm definitely happy to do calc for sure. Let me just find the answers and we'll be ready to go. Right. Let's get this going. Right, we've got calc open, ready to rumble. Lost some brain cells trying to do prob. Most people voted calc. I said I was going to do calc. I've confused myself, but hey, let's do calc. I know I said we'll do prob on the Reddit, but let's do calc. Some more follows. Thanks for the follows, team. Right, let's get this back sorted here. We've got the calc ready to go. Okay, I've done some calc on here before. We are doing the 2016 paper. 2016. I've done the 2017 one online before, I'm pretty sure. So we're doing the 2016 one. I've got the questions. I've got the answers. I've got the answers there. You can see that, alright. Tell me if there's bad quality of anything, but we should be ready to rumble. Let's kick into it. 7:15. We can whiz through this. I'm probably going to skip maybe the E questions, come back to the E questions at the end. We'll see how we go. I'm not going to reteach differentiation, right? I'm just going to focus on some key questions. Like these questions are very important, and some others. So let's just get straight into it, eh? Right. Let's look at this first one. You see that all good? Good, good, good. Right, ask questions, please, please, please. A function is given by this, blah, 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 blah. Find the gradient of the graph. So the type of question. We're going to highlight types of questions in orange. This is find the gradient type question. Okay, which means we diff and sub. The process we are going to do is diff and sub. You'll hear me say this 1,000 times. Diff and sub. Okay. Two-step process. First of all, we differentiate. So we've got f of x, let's find f dash x times by the power, take 1 off the power. 12x squared minus 14x plus 2. We drop the minus 4. Right, and then we're going to substitute in, I'm going to highlight important things in this color. We substitute in x of 2 equals 12, 2 squared minus 14, 2 plus 2. We type this all into our calculator. Should be 48 minus 28 plus 2, which is, what's 48 minus 28? 20. And plus 2, 22. That's my final answer. Tell me if you got the same thing. Let's get rid of this. Yes, it'll be uploaded, don't you worry. Okay, it also is available on Twitch. You can just see it. It's really warm in my room. I'm just going to open a window. 1 second. Right. Okay, so let's do the next one. Now the next one is a money question, right? This is a equation of a tangent type question. Let's have a look at it. The line is a tangent to the curve. We like these questions. We want to do this type of question, right? No worries, Pip Mun. No worries. Right, we've got this. This is essentially saying the answer is this. Prove it to me. Here's some other information. Right? So, the answer is this. We are allowed to use information from the answer. We've got our function. Now, because we're doing the calc paper, we're probably going to differentiate, and then we're going to use an equation. So, let's differentiate this first. 6x minus 2. I'm probably going to make mistakes, so you're going to have to correct me. 6x minus 2, and the point where this tangent touches the curve is this. So we can sub in just going to show that the line is a tangent to the curve. Yeah, so we can use f dash 0.5 which equals 1. Okay, and this is essentially your m in the equation that we're going to use. Now that equation, I'm going to write up here. Now you might have learned it a different way. If you did, that's cool. You can learn it that way. I like this one because we have these 3 bits of information here. So we've got m, which is this piece here. The gradient by definition is m. M is the gradient, is the slope. Okay. We now have y1 and x1. And we've got y1 and x1 here. So let's sub it into that equation, rearrange it till it looks like our answer. So y minus, instead of y1, I'm going to write 3.75. Instead of m, I'm going to write 1, x minus 0.5. Instead of x, I write my 0.5. That all came from those bits of information there. Now I can 1x minus 0.5. I've expanded the 1. And I'm going to move, or I might put this in here, 3.75. Right? Tell me if I'm writing too small. I think this might have fixed the problem of writing too small. Y equals 1x minus 0.5 plus 3.75 because I've moved it across. And this becomes y equals 1x plus 3.25. And would you look at that? We know we are right because this is the same thing as this. So we know we've done it right. That's really good because we know that's worth a merit. You look at this, oh my goodness, it's a merit. Well done, sir, you're amazing. Well done, your team. Thank you, Pipman. Right, any questions or we carrying on? We're just whizzing through. Right, let's whiz on through. Scroll up to the last question on the page. Is that with A or M? That's with a merit. First question was with an achieve. Next question was with merit. And we got that right. Well done. Okay. Let's have a look at this one. This one involves turning points. And that uses this key bit of information here. Let's just get rid of this. Put it over here. Right. This involves this key bit of information. Okay. The key bit of information is there's a turning point at f dash x equals 0. This is so important. Okay, this is so important. There's a turning point at f dash x equals 0. See you later, spaghetti, if you're going. Enjoy your physics study, mate. Right. This is fundamentally important. Okay? I'll show you why. With this function here, let's differentiate it. F dash x 6x squared plus 2kx. Oh, not plus 5. Done. Okay? We've got this here. Right? Now we have a turning point at x equals 1. These are our key bits of information. What do we know about turning points? Well, I've just said that at a turning point, the gradient f dash x equals 0 at a turning point. So, this piece here we can replace with 0, and because it tells us some information about it, it says the turning point is at x is 1. We can replace the x's with 1s. And that's going to help us find this k, because k is the real problem in this question. Okay, once we replace this, we can actually solve this. 6 plus 2k minus 6 equals 2k. K equals minus 3. Sorry. K is minus 3. Once we've got that, we can now re-put this bit of information into this equation and go from there. So f dash x equals 6x squared. Well, it's not plus 2k anymore, it's, or I might go 2 minus 3x, which is the same thing as, that should be a plus, minus 6x. Right, we've got this here. So far so good. Right, what are the coordinates of the maximum point? So we need to find the coordinates. Well, we've got one x value. Right? Oh, we didn't even need to do that. We've got an x value. We now want a y value. Okay, so we can literally just use the original function. Minus 3x squared plus 5. So that's the original function over here. And I'm just rewriting it here. And I've replaced it with what we know about k. Alrighty. So, we've got that there. We are going to substitute in our x to find our y, because this f of x is essentially y. Not essentially, it is. This is 2 minus 3 plus 5. You can type this into your calculator, but this is, this is 4. Yes. So this is 4, our x was 1, so our coordinates are 1, 4. And it doesn't say we need to prove. If it says we need to prove, we go on and double diff, but it doesn't say we need to prove. And I guess the reason why is because it says, oh, I've just found the coordinates of the minimum. Oh, I've gone down the wrong rabbit hole here. That's okay. Good to know. We can erase some of this. Right? Because I didn't read the question carefully. There's a minimum at x equals 1. We want to find the maximum. Right, let's backtrack this. No one called me out. I told you I'm going to make mistakes, team. Right? Let's solve this. Okay. We've got this equation here, which is, I've changed this to 0. And I've got my function. If I solve this quadratic using the calculator, right? Use the calculator to solve, then I will get two answers. One will be x is 1, and the other will be something else that we're not sure about. So to do that, we go over here. We go equation. Where is it? I've got an old calculator. It doesn't look like this. There we go. Equation. Polynomial 2. We've got 6x squared minus 6x plus nothing equals 0. So one of them is 1, or one of them is 0. This one is a minimum because they told us, which means this one is a maximum because it has to be. Right? You have to have a min and a max, like opposites. To find the y value, we put it in. Now we put it into the original function. That's my fault. So now we're going to put in our x value of 0 which equals 5. So our coordinates are 0, 5 of the maximum. Sorry, I made a mistake there. How do you know you have to have a max and a min? So that's just how it works. It doesn't make sense. Let's have a look. Good question. Really good question. Let's just use the extra paper that's required. Right? If I have a graph, this is a cubic, right? You can't have a cubic that has like 2 maxes. I just tried to draw that. It's really hard, right? Or 2 minimums. If you have a minimum, you have to have a maximum to return. If you have another minimum like that, or 2 maxes, up and then up again, you have to have a local minimum somewhere. So every cubic, especially every cubic you guys will have to deal with, has a max and a min. Right? Has a oopsies, max and a min. Max and a min. Does that make sense? Storm 97. Does that make a bit of sense? Hope that makes sense. Right. Let me know if it doesn't. You can prove that this is the maximum later on. We'll show you later. What about cubes that have a point of inflection? They're sort of weird. Like this, right? Where you go. I mean, they don't really have a max or a min. Oh, engineering grade. Good. I like it. Right, they don't really have a max or a min, points of inflection ones. And I think there'll be... I'll talk about that soon, because in some questions you'll be asked to prove it, and we'll prove it through... There's an inflection one. Oh, this one here, E, question E, that you can see, is got a point of inflection. I'll talk about it in a minute, yeah? Glad you guys are here. Right, the equation of a function, blah, 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 is this. The equation of a function y equals f of x has a gradient function in the form of f dash x. Is this, whereas the turning point is 3, 4. What do we know about turning points? This is y dash equals 0. Right, so we've got f dash x, right? When we are given f dash x, we should know that we have to anti-diff. Right, let's just check we got that last question, right? Yeah, 0, 5, nicely done. Okay. So, when we've got the gradient that's already given to us, the derivative already given to us, we should automatically think, we anti-diff. And when we anti-diff, we always anti-diff plus c. That's why I've written it here, so you don't forget the plus c. Okay? Anti-diff plus c. Before we do that, we have this weird a, and I've written it sort of like a 9, so I'm going to erase it and write it as an a. We've got this a. Can we get rid of it before we anti-diff it? Or do we need to do it afterwards? Let's have a look. The 0.34 occurs at the turning point. We could probably do it either way, to be honest. Let's try it now. This is x, this is y. So the 0.34 is the turning point of the graph. Oh no, you have to do it later. Oh no, you could do it now. You can do it now, right? So what do we know about turning points? They have a gradient of 0. So 0 equals 2 x minus a. But instead of x, we know that that turning point occurs at this point here, where x is 3. So I can replace things I know about x with 3 instead. Now I can solve this. And therefore, oopsies, 6 equals a, or a equals 6. Now we can replace in the original function up here, we can replace what we know about a with minus 6, and now we can anti-diff. Let's go over here. When we anti-diff, we add 1 to the power, divide by the new power. Add 1 to the power, 2x squared, divide by the new power, 2. Good. Minus 6x, because we just add 1 to the power, and just becomes an x. And don't forget the plus c. Let's simplify this. X squared minus 6x plus c. Really good. And now we need to find this plus c. We've been given 2 sets of coordinates over here, so we're going to reuse those coordinates over here. The y goes on this side, and the x is 3, so we replace every x we see with a 3. 3 to 9 minus 6 3 is 18, minus 9 plus c. Add this one, 4, 9 plus 13. So our final equation, f of x, x squared minus 6x plus 13. I might have made a mistake. Let's check the answer. Oh, I'm good. And that is worth an excellence. Whoa, that's worth an excellence? Whoa, I thought that'd be a merit. Why do you say 2x squared over 2? So when we anti-diff, Dango, when we anti-diff, we add 1 to the power, divide by the new power. Let's have a look, right? Let's get rid of this. So we had f dash x equal to x, what was it, minus 3 maybe, I think, something like that, right? We add 1 to the power, 2x, this is originally 1, so we add 1, that's going to be 2, and then we divide by the new power. So we divide by the new power, which is 2. Simplify that, and you're going to get x squared. Add 1 to the power, divide by new power. That's anti-diff. Anti-diff. My handwriting's getting real bad. Look at that. Anti-diff. And next, does it matter if the c is positive or negative? Yes. If the c is negative, if this was minus 13, then we would write minus 13 here. The reason why we just have, I get where you're coming from with the question. Over here, we make it plus c, right? And plus c and plus c. And imagine if it became minus 13. The reason why we use plus c is because plus, if you plus a negative number, if you plus minus 3, it just becomes, oh, it's outside of the page. If you plus minus 3, it just becomes the same as minusing 3. Okay, so it doesn't really matter, but you have to keep it as whatever answer you do. If you keep your maths pure, it'll pop out as whatever sign it is, and you make it whatever sign it is there. Okay, we just got an excellence, fellas. And fallacies? Fallacies? I don't know. Let's do this one. We're going to investigate this question. I think these two are, the last question, that's quite tricky, right? It's quite tricky to understand the question. This one, I think it's not too hard, but it's worth an E, so I get really excited because I don't think it's too tricky. I know how to approach it because I think the reason why it's nice is because there's not many words. I don't like lots of words. I just like it as is. This looks important, and this tells me what type of question it is. When I see min or max, I think of this. Double diff. Right? And the way I remember that is min max has 2 options, increasing decreasing has 2 options, double diff has 2. Okay, min max increase decrease double diff. It sort of like fits in nicely. That's my knee-jerk reaction to that type of question. Remember, we should see a type of question, respond accordingly. So here's our knee-jerk reaction is to double diff, because that's going to test But firstly, we look at this and it doesn't look like we normally see it, because we don't normally differentiate when there's brackets and stuff. So we need to, excuse me, expand this one. So this is we're gonna do this, like this, and we're gonna get x to the 4 minus 4x to the 3. Which is a little bit weird, but let's just follow our noses and see what happens, because we're trying to double diff. Right, we're trying to find the local minimum and figure it out. So we know we need to diff at some stage. So let's diff it now. 4x3 minus 12x squared. Okay. Now, we know we're going to double diff soon, but what do we know? Minimums occur at a turning point. What do we know about turning points? It's one of our golden rules. Our turning point is at y dash equals 0. So we replace y dash with 0, and we'll be able to find the x value at the turning point by solving this on our graphics calculator. You could solve it by hand. We're not Neanderthals, so we don't need to do that. Okay, we live in the new age, new era. Now, normally we go degree 2 because it says x squared, but this one, it's a little bit different to how we normally see it. It's x to the power of 3, and you can see our calculator has it written up there, how we like to see it. So, we've got some number in front of x3, 4. Some number in front of x squared is minus 12. Some number in front of x, well that doesn't exist, so we're going to say 0, and some number, that's going to be 0. We solve this one, we find this here. X equals 3, x equals 0, and x equals 0 again. Let's just move this over a bit. Okay, so we've got 3 options, which makes sense because our curve is not a cubic. It's I don't know the actual word for it. Some of these guys in the chat might be able to help us, but it's threic, not 2 humps, but 3 humps, like a camel with 3 humps. Right. When I do this, I then split my page up. Thanks for the follow, Big Kahoot. I split my page up like this. What I'm actually going to do is we're going to do some maths for x equals 0. Let's get rid of that, because it's essentially going to be exactly the same thing. Right? Let's do it like this. Right. So, in each of these columns, we're going to double diff and find whether it's a max or a min. A quartic. Very good to know. Cubic and then a quartic. Thank you. Y double dash. We're going to double differentiate this one here. So this one's already been differentiated once. So again, we're going to get 12x to the squared minus 24x. And same thing. Nothing changes on this side. All that changes is that we're going to sub it in. Nice straight lines. Thanks, my dude. Okay. We're going to sub in this value into these x's. And same thing over here. We're going to sub in this value into these x's to do the double derivative test. It's nice having people much smarter than me in the chat. I find it a bit daunting. I'm going to make some mistakes and you guys are going to call me out. I'm an ex-engineer. Poggers, hey, Zola coming at me. Right? So, the double derivative here. Now, I can't do that in my head. Well, I probably could, I don't know, 9 times 12. But let's just type the whole thing in exactly as we see it so we don't make any mistakes. Minus 24. Boom. So we get 36. And we're going to do the same thing, but instead write zeros. Put a 0 there. And we get 0. Right. Now, this is how we do it. Is 36 greater than or less than 0? I think we all agree that 36 is greater than 0. Now normally this would be a minus 36 and would go less than 0, and this would be a max and min, but it's not the case. We'll talk about that in a second. All I know for sure is that this one is greater than 0, therefore it is a minimum. I'm going to show you a cool way to remember that. Oh no, go to the last page. Right, I'm going to show you a cool way to remember that. Right, if 36 is greater than 0, if you imagine getting this thing here, right now it looks like this. If I grabbed it, can I do this? Oh, I can't. Okay, no. I was going to try to see if I could do it. If I tilted it to the right, like came and knocked it and it tipped over to the right, it would become a V like that. Now that V is the shape of the curve, and you can see that that is a minimum. If it was this, minus 36 is less than 0, we tip it to the right, it would become an upside down V, and that would be a curve like this, and that would be a max. That's how I remember it. Some people might remember it's just backwards to what you imagine. The big one makes a min, the small one makes a thing. I remember it like this. I imagine Sunny Ball coming in, giving it the big sit down, boom, it tips over, you get a min and a max. That's how I remember. If that helps, cool. If it doesn't, no worries. Right, just a little memory thing. So we see this one, I tip it to the right, I know it's a min. Right, this one over here, I tip it to the right, boom, therefore it's a minimum. Luckily the question says find the local minimum value. So we've got the x value. There's a minimum at x equals 3. How do we find the y value? Well, let's cut our page off and carry on working. So we've got our original equation. Oh, it's not f of x. We've got an equation for y. X to the 4 minus 4x 3. That's this one here. We've got our equation for y. So we're going to substitute in x as 3. This one over here. Let's use a different color. Green. Because we're on the home straight. For each x value, I'm going to substitute that in. So instead of x, I'm going to write 3. And instead of x again, I'm going to write 3. I can't be bothered doing that in my head. I think you did this page already on my YouTube. Are you sure it wasn't the previous years? Maybe I did. I got a memory like a sieve. Been some Fortnite next. We'll see. I got some friends around. Maybe I'll do same with them. I don't know. I got a pretty free week, so I'll be playing some games this week. Right, y is minus 27. Therefore, our x and y values are 3 and minus 27. Okay. So already done this whole paper. That's annoying. Right, so we've got 3 and minus 27. Let's check our answers. Make sure I don't make any mistakes. Boom. Must be justified. We justified it through the double derivative test. Double E. After finish, can you explain how I knew to double diff? So essentially I have done this several times, right? In terms of this question, it says justify your answer. To be able to justify whether something is a max or a minimum, we do this test here, the double derivative test, right? Where we double diff it and do this thing to know whether it's a max or min, the Sunny Bill test, right? Every time it says max or min, I automatically think that, because I know the only way to know if it's a max or a min is to double diff and then use the Sunny Bill test. That's how I knew to double differentiate. And because I've done a bajillion questions, I know that this question means I double diff, carry on going. It's not a very satisfying answer. But mathematically, the reason we do it is because this double derivative tells me where it is. I could take it back to fundamentals, but that tells me. What device am I using? I'm using the iPad 9.7 2018 version. I bought it about 4 days ago. It's making these streams much better. Okay, cool. Right, we've got this one here. I don't like these questions. I think they're silly. I'm going to teach it very quickly. Right, we know that this is some sort of x to the 3. This is f of x. Right. Oh, let's move it across. Okay. The derivative, because we've got the function, we want to sketch the derivative. The max would be at x0 for this curve. Yeah, good. Good. Oh, I missed that question. Thanks for that. So the derivative of this would be 3x squared. Okay, the key is that it's something x squared. So, I know that this shape is going to be some sort of parabola, either like this or like this. The way I remember it is like this. Now we've got to zoom out a little bit so we can see the whole thing. Is this plus minus business. Now let's get some nice, maybe some orange lines. How's this for a straight line? You guys were insulting my straight lines before. How's this? Boom. And this one. Boom. Nice. Right, so we've got these turning points. Now remember this, in life the only important things are the turning points. Okay? Turning points are the important things in life. Turning points are the important things of the cubic. Okay? So, this point here and this point here are the important points on the graph. Thank you, Vasa. Right. Now to remember what to do, when it is increasing, when the graph, the original function is increasing, it sits in the positive realm. So we go plus, minus. Okay? Plus, minus. When it is increasing, it's in the positive realm. When it is decreasing, it's in the negative realm. And when it is increasing again, it goes into the positive realm. What does that look like? Well, it's increasing first of all, so I'm going to do line to here, and I know it's going to look like a parabola. Now it's decreasing, so it enters the negative realm until it hits this point and increases again. Okay? X equals 0 twice. Rockefeller, I'm not sure what you're talking about. Sorry. Let me know what you mean. It looks like what of this now is onto it. Right? That's all we do. It's only worth achieve or merit. It's a silly. Let's have a look. Only worth achieve. I would happily let you just skip it. I won't be stressed. Okay? Sometimes they're worth merit. I don't really care. These are the money questions. Equation of a tangent. We get excited by it because they're not too hard. Right? Find the values of a and b. We need to rearrange it towards the end. Oh, it's x equals 0 twice because it was... Oh, I see where you're coming from. I can explain this. The actual graph... it was a minimum, right? The actual graph looked like this. Okay? So, if you imagine... Normally... the graph would look like that, an x to the 4. Okay, it would have 3 turning points, 1, 2, 3, all at different, this is your x-axis, x values. -3, 0, and 1. Okay, but here, what the actual case was, this can go away, what the actual case was we had a point of inflection here. Let's highlight it instead. We had a point of inflection here. So we had our turning point at minus whatever 3. But then our point of inflection was actually at x equals 0. It's the x-axis. So when we solve it like algebraically using our calculator, we get x equals 0, x equals 0 twice. That's why it works like that. Okay, because it needs to have 3 possible solutions, so it gives you those ones twice. I hope that makes sense. Right, it's sort of how I imagine it is that it goes in and out, and that's why it's got 2. That's not mathematical, that's just how I think about it. Okay, that's why it does that. Really good question. I'm loving the like deep thinking questions. Let's tackle this one, and we'll pick up the pace a bit and truck away as we go. Right. So we've got this one. I think straight away we are doing a equation of a tangent y minus y1 equals m bracket x minus x1. We've got to memorize that formula. There's no two ways about it. You say it 50 times, you'll remember it. Right, let's differentiate. Y dash equals 2x squared minus 3x plus 1. Oh, I didn't even differentiate. I just rewrote the function. Let's go like that. Cheat. Now y dash equals 4x minus 3. Okay. Kind of physics tutorial. So I'm still not sure how x equals 0 twice changes the graph compared to if x is 0 once. If x equals 0 once, if x equals 0 once, it would look like this. Right? And you'd only have 2 x values. This has to be a y equals x to the 3 graph. We had a y equals x to the 4 graph, which means we have to have 1, 2, 3 humps. One less than the power. Yeah, spaghetti's on it. Oh, Dewey's here. Nice Dewey. The mods are back in town. Right? So, x to the 3 means we have to have 3. Sorry, x to the 4 means we have to have 3 humps. X to the 3 means we're going to have 2. Our solution gave us 3 answers because it was x to the 4. It has to give us 3 answers. Right? Okay, he's with me. 2 come from here, the point of inflection, and 1 come from here. If it was just this one and this one, it would be a cubic, but it's actually a quartic, which I've just learnt today. Gotta get them fat grades for level 2. My man. That's what prefix are about now, huh? Good. Right, back to this question. Drink of water. We're gonna whiz real fast. Yeah, lots of students in real life. Yeah, I know a couple of these guys. Right. Y dash, so we're gonna sub in values. Y dash equals 4. Instead of x we write 2, which has come from, we're going a little bit fast now, come from here. Minus 3. Do you like the new setup, man? That's for damn sure. You like the new setup with the, I got the Apple Pencil. This is like $160 or something stupid. Right, Apple products are a rip-off, man. They make me sad. 5. Okay, this is by definition the gradient. So y minus y1 equals m x minus x1. I know I've rewritten it. I'm rewriting it so that you keep remembering. This is x, this is y. 5x minus, oopsies, 2. Weird flex. Hey, what the heck, man? I'm so proud of this. I'm so proud of this setup, man. It's like got colors. Before it was like black and white, hard to read, really small. I thought teachers were broke. Yo, I am broke, especially after this purchase, man. Oh, that should be a minus. Y equals 5x minus 7. These are the money questions, team. Oh, A equals 5. B equals minus 7. You've got to be able to answer this one. Right. From the 5K last week. Yeah, baby. 5K prize, man. 5K prize. I finished my studies, so I thought I'd reward myself. Right, let me know if you've got a question about that one. We should be nailing that one. Let's look at this last one. Oh, I don't like this last one. Oh, this last one's hard. Hard to explain, hard to do. Are you guys feeling up for it? So I double my teacher salary. Well, no winky face needed, man. You're not wrong. Okay. This last one's tricky, man. But then it's... Oh, it's two tricky ones in a row. Right. Do we want to come back to the two tricky ones at the end? Boom, boom. I feel like we want to get on a bit of a roll of some easy ones. Then people can check out if they just want to do this. And we'll come back to the tricky ones. I think we should come back. So just say yeah, come back, or nah, move on. Yes, come back. Nah, do them now. Are your two options. I'm gonna assume we're gonna come back to it. We'll smash these last ones. I'm really excited for the probability stream. I've spent a lot of time on it. Look, I've got like some nice looking probability stuff. Oh, that's not it. Oh, it's gone, dude. Look, here we go. Oh, it's not even... What? Oh, look. Oh, beautiful looking probability. I'm excited. Yeah or nay? Yes, come back. Okay, we're gonna come back to it. Right, I'm just flexing on my probability notes. Right, we're gonna come back to it. Dewey, you're gonna stay and come back with me. Okay. Right, I'm expecting heaps of us to stay. Let's tuck into this. Right. What do we know to do with this question? We know it's a antidiff plus C. Antidiff plus C. How do we know? Because they've given us the derivative. Okay. Weird flex, but okay. I think it's a good saying. Weird flex, but okay. Weird flex, but okay. Right. We're gonna antidiff plus C. Add 1 to the power, divide by the new power. 3x to the 3, divide by the new power, 3. Minus 5, add the x on, and plus C. Let's simplify this. Ooh, 5x plus C. And now we need to find C by subbing in this one here. Let's highlight it better. So 0 equals 1 to the 3 minus 5 to the 1 plus C. Okie dokie. This is 0 equals minus 5 plus C. 5 equals C. Original function, y equals x to the 3 minus 5x plus 5. Let's see if we got that right. Plus 4. What did I do silly? Oh, I'm silly. I'm really silly. There should be a 1 there. 1 minus 5. I thought that was wrong. Silly mistake, that's fine. Yeah, there we go. Now you're all catching up. Good. You're all awake. Good, 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 good. Right. Another one of these ones. Ugh, they're stupid. Right. This is f dash x, and it's gonna be x squared. So when we get f of x, it must have been a higher power. Right, something x to the 3. So I know my graph is gonna look like either like this. Oh. Or like this, but prettier. Right. Okay, let's get our beautiful straight lines. Don't laugh at me. Oh no, our straight lines are different this time. Because we're coming from the derivative like realm into the real realm, it's the opposite way around this time. So the x-intercepts are important. I've been streaming 1 hour, but we didn't start after a bit, so it's been loosely 1 hour. Right, those aimbot lines. So the increasing parts are here, and the decreasing parts are there. Right, so we're gonna have a turning point and a turning point. As it's in the plus, it is increasing. It then starts decreasing until it's here, and then it's increasing again. Something like that. All it needs to do is hit those 2 points, and you get merit. If you get a cubic with the correct turning points, you get it. I don't mind if we just skip those. So let's move on. This is a fun one. Kinematics, let's do it. It's getting a bit tricky. Ninjaza? I wonder if that's Ninjadu. My mate Ninjadu. Okay, let's look at this one. Good old Meg. Silly little Meg. Right. We've got lots of information here. Meg is riding her motocross bike. When she passes a fixed point P on the track, she has a speed of this. She has an acceleration of this. This is at P, at P. If she would continue to accelerate this way, what is her speed when she's been riding for 10 seconds? Right. We remember Diva, don't we? Diva, the character from Overwatch. Man, my mind's I'm going crazy. Right. The character from Overwatch, Diva, and we diff down, and we go up. Okay. The character from Overwatch, we diff down, and we anti-diff on the way up. So if we want to get from this round, this round, this round, we're going to do it. Let's start with the acceleration. This is a point thing, so we're not going to worry about this. Let's start with acceleration. If she were to continue to accelerate at this rate, so she still has acceleration, what is her speed when she's been right? So we need to get to speed. To do that, we anti-diff, so 0.6 will become 0.6t plus c. Right? S is displacement. Yes, you're right, but it doesn't look cool. And my S's and my 5's, my S's and my 5's look very similar. So S's is a bad letter to use in maths. So I'm not going to use S for displacement. And S for displacement, whoever came up with that? That's weird. Okay? So, we've got an equation for V, but we've got the C in there. This is where stuff gets a bit funky. Right? When she passes a fixed point, she has a speed of this. We start the timer when she passes that. Okay? Because we're doing 10 seconds after P. So at T of 0, V is 5. That's what this information is saying. Or at T of 0, V is 5. That's that information there. Right? So we can use that to solve this. V is 5 at T of 0. Now, you can solve this mathematically. You'll find that 5 equals C. We can always think about it as well as C being the initial whatever. So if this is Fanta, if this is velocity, then C is the velocity at time 0, the initial velocity. Okay, if this was distance, then C would be the initial distance, the distance at time 0. Right? But we can just solve it mathematically. We get our equation for V equals 0.6t plus 5. We've got our equation for V. We're going to sub in to find what is her speed. This is what the question wants, her speed at 10 seconds. So, her speed, V, 10 seconds. Which is V is 6 plus 5. V is 11. Now that might be a hard achieve or a merit. Nice, that's a merit. Well done. Okay, good. How far will she travel? What does how far mean? Far, not like the Vietnamese noodles, far, but how far will she travel? Like in the new setup. Thank you. Thank you. That's all I needed to hear, Dewey. Thank you. Far means the distance. To get... Oh! What the heck? Oh. I just scratched my screen a little bit and it just went crazy. Okay. Big Kahoot. I haven't even seen you here before, Big Kahoot. So, how do you know what the old setup is if you've never been here? Unless you've been lurking. Right. Far means distance. Let's do this question. Far means distance. Okay. How far to get from V, this equation, I'll write it here. V is 0.6 t plus 5 to D. We anti-diff one more time. Add 1 to the power, divide by the new power. Good. Okay. What is her distance from P? This is P. She starts here at time 0. Hey Ollie, at time 0, her distance from P, she starts at P, so her distance from P must be 0, right? I have a static signal coming out. I can't bother doing it. Subbing for me. Yeah, I got you, dude. No, I wouldn't want to do a static signal either. Or external. Her distance from P must be 0. So, remember, initial whatever this is, initial this is your C. But we can also sub in. At time 0, D is 0. Right. Yep, I haven't missed any information. Hopefully we're okay with that. Alavni? Thank you very much for the follow. Okay. We've got this distance. Right. So how far will she be when she reaches the speed of this? So we can find the distance if we're given a time. But we're not given a time, unfortunately. Okay. We're not given a time. We are given a velocity. So we've got velocity. We could have done this earlier, but that's fine. We've been given a velocity. So we can find the time at that velocity by substituting in the velocity and solving. 8 minus 5 is 3. I don't know what this is. 3 divided by 0.6. I should know this. All them straight lines. I know, dude. Thought it was physics at first. Yeah, this is pretty similar to physics, to be honest. More the math side of physics. Oh yeah, my title's true. I remembered at the last minute. Calculus. Thanks for that. Right. Physics just applied math, you should be fine. Right, t is 5 at this speed. At v equals 8. So we can use this information that we've just got to sub into here. In here. 0.3 5 squared plus 5 times 5. I feel I might have made a mistake somewhere, but let's have a look. Zero point 3 5 squared plus 5 times 5. Oh no, that looks right. 32.5 meters. Let's check our answers. 32.5 meters. That's what we got. Well done. With excellence. Well done. Units not required. It's not 0.3. Ah, spicy. Where's not 0.3? This one here. That came from 0.6 divided by 2. 0.6 divided by 2. I think we're good, dude. I think we're good. But I'm glad you're trying to call me out. It's supposed to be 0.6, doesn't matter. Especially, do you see how it's 0.3? Let me know. 0.6 divided by 2 over here. Right, now, potentially the hardest to understand, but not that. Or, we're hitting the 3 hardest E questions in the paper. So, if you're only here for the achieve merit stuff, please don't leave just now, because I need to get your help with doing something, please. I'm going to make this thing ability to respond, accepting responses. There we go. Exclamation survey, exclamation form. Sorry, exclamation form. Before you go, big hoodah, please complete the form. If you're sticking around for the E stuff, awesome, complete the form afterwards. But if you're not, no worries. Go study the achieve, study merit. Good luck for your exams. See you on Friday. I think we're gonna do probably on Friday. I'm in the zone. Right, we're gonna do some hard questions now. Thank you so much for tuning in. We're really on track. We're really whizzing through. Okay. We've got spare grids. Right, we've got 3 E questions to go. We'll see if it takes us 45 minutes, but I doubt it. Maybe we'll have some time for some games. Right. Meg's friend Leo was with her. Probably the only one you know who passed. Watch this video afterwards, Fast Trickster. See if it helps you. Right, let's have a look at this one, because we don't want to lose track of Meg and Leo. So Meg, so we've still got all Meg stuff. So let's grab Meg's information from before. We had her velocity, 0.6t plus 5. Her distance was 0.3t squared plus 5t. Okay, we've got this information, and apparently now Leo was riding with her, but he begins to decelerate when they reach 8 meters per second. What time was this? Because we just figured that out. Remember, over here we did the time at 8 meters per second after 5 seconds. So this question is actually saying, so we're flicking around a lot, but that's because we need to. This question is saying Leo was riding alongside Meg. After 5 seconds, he was like, nah, I'm good. Right? Oh, that's fine. Let that go. How do I unblock that one? Sorry, dude. Unban. Okay. Right. So, Meg and Leo are going alongside. After 5 seconds, Leo drops off. Right? After 5 seconds. So, this is his 32.5 meter mark as well, isn't it? Right, we just figured that out in the last question. Oopsies. Right. So after 32.5 meters, or 5 seconds, or 8 meters per second, he then begins to decelerate at 0.2. This is literally the same question as before, and now it's with excellence. Okay. Yeah, I saw what it was. Sorry, mate. Right, so let's have a look. If his deceleration is minus 0.2, because he's decelerating, then his velocity would be minus 0.2 t plus c. Right? Now this is where it's interesting. Let's draw a little track. What color is our track? Like an orange track. We've got this little orange track. And we've got Leo. Leo, what color is Leo? Leo's like a light blue. We've got Leo at the start. There's just going to be people. Okay, Leo at 32.5 meters or at 5 seconds. Right. Thanks for the follow, dude. At 5 seconds, he's up here, and he's also going 8 meters per second, and he begins to slow down. He's going to slow down till this point here, which is when his speed is 6 meters per second. We don't know how far away he is, and we don't know what time it is. So these are unknowns. Let's put them as question marks for now. So knowing this information, what is his initial velocity once he starts slowing down? Right, once he starts slowing down, this stuff here is only relevant for this distance. This stuff here is this distance. So at the point where that transition happens, what is his initial velocity? Well, his initial velocity is going to be 8 meters per second. So our C is going to be 8. Let's make that a bit neater. Now if that doesn't make sense, I can prove it mathematically. But if it does, awesome. If it doesn't, I'll show you mathematically, but I'll delete it. His velocity is 8 meters per second. Wait, how's this going to work out? That definitely works. That should make sense. Let's check the answer to make sure. Yeah. Okay. If that doesn't make sense, let me know. I feel I'm going to make a mistake if I try to prove it mathematically. Makes more sense to me to use logic. Okay. Remember, C is his initial velocity. So his initial velocity is 8 when he's at this time here, because we're restarting the chunk. Okay, so looking at this, we've got the equation for velocity. Right? We want how far. The question says how far, so we want the distance. So the distance is going to be minus 0.2 t plus, or oopsies, t squared over 2 plus 8t plus c. You with me? Chat's gone quiet. Tell me that you're still with me, team. Now what's his distance at this time here? His distance at this time here, we're essentially resetting the clock. Now it could be 32.5, it could be 0. I'll just double check and see which one makes sense. Yeah, I think it's 0.2. Okay. So, how much I don't really understand this stuff here. Oh yeah, that's fair enough. There's no helping you in that son. I'm currently processing and focusing. Okay, good. Right. So, we've got this equation for distance. Because we're essentially resetting our thing when he starts the deceleration process. His distance at this point here is 0. And that's essentially where our time is resetting at 0. Okay, we're resetting the clock. Right, we're resetting the clock. So his distance is 0 at time of 0. So our C is going to be 0. We could chug through the maths mathematically if you really wanted, but I'm confident with that. Okay. So our equation for distance is minus 0.1 t squared plus 8t plus 0. Because we're resetting the clock at that point there. Right? So, if this is our distance, let's do what we were doing before. Let's read the question very carefully. How far past point P when he reaches a speed of 0.6? Right? When he reaches a speed of 0.6, we had to do the same thing last time. Right? Yeah, I've got a timetable. It's up when I close it. When I close the stream. How far past the point when he reaches a speed v of 0.6? Well, our velocity is minus 0.2 t plus 8. That's our equation for it, right? We want the time at this point when it is 6. I'm getting it from up here. Right? Minus 0.2 t plus 8. We're going to minus it over across. Thank you. Minus 2 equals minus 0.2 t. This should be 10, but I'm just going to double check my maths because I'm never sure about this. Oh. Good. So, at the end here, our brother Leo, at the end here, we know the time is 10 seconds. We know the velocity is 6. We need to know the distance. Well, we've got an equation for distance, so let's use it. Minus 0.1, and instead of t, I'm going to write 10. Let's type the whole thing in. Minus 0.1, 10 squared plus 8 to the 10 plus 0 is 70. Okay, so he's gone 70 meters in this final stretch. Right? Now, if we look at this, thanks, Kahoot. I'll let that go through too. If we look at this, we've got the first chunk where he was chilling with Meg. Then he ditched Meg and said, "No, Meg, you're going too fast, I need to relax," and started decelerating here. This distance is 70 meters. This distance is 32.5. So the total distance, 70 plus 32.5, is 102.5. And that's the total distance there. So dude, the chat's on like hyper police mode. Nightbot goes crazy just because I've had some bad experiences. 102.5. Oh, I missed it. Now I know that's tricky. I know it's hard. Okay. I know that's quite tricky. Right. What we're gonna do is go to the next one. It's not. I don't think it's as hard as that. This one here, or maybe. It's got some funky stuff in it. What we're going to do is we're going to erase some of this. We're going to scroll it right up. And we're going to smash this question. Okay. Can't use this. I agree with what of this now. Can't you use SUVAT equations? Yep, but not in a maths paper. Oh, my windows is still open. I want to shut my windows. Hold on. It's cooled off a bit in my house. He's talking about like the VF equals VI minus half AT squared and stuff like that. The thing is, Jam Fam, in this paper, we are testing your calculus skills. So you need to show your calculus skills. It's like if I don't know, go, I don't know, do an algebra test and do everything through guess and check. I'm not showing my algebra skills. What's the point in doing the test? You know what I'm saying? You've got to show your things. Oh, dude, it's not my house. I pay an exorbitant amount of rent and have very little spending money and spend my extra time doing free tutorials. That's the worst flex in the world, man. Right. Let's do this one. It's going to get a little tricky. Don't you worry. Right. Oh, this isn't even that bad. I thought this was a different question. Oh, I thought this was a whole different question. I thought it was this question. Okay. Let's do this one real quick. This isn't too hard. This is... Okay, oopsies. The gradient of the... there's this question over here has A in it. And this one has A in it, so I freaked out. Right. Okay. Right. The gradient of the graph of the function blah 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 where x... Okay, this is where this one's weird. The gradient and all this other crap like doesn't matter. How do I want to make like an aggressively red highlighter. Okay. Yeah, nice. Let's delete it. Hold on. Delete. Yeah, good. All this is useless, right? Not useless. It makes sense. But the gradient where x is 1 is 3. Y dash is 3 at x equals 1. Right? Heaps of people will misread that and do badly. But if we read this, thanks chill. If we read this, or they'll also differentiate this wrong because it's written a different way. The gradient where x is 3, where x is 1 is 3. Let's differentiate because we know we probably have to. The 2 disappears. The minus is attached to the 4, so it's going to be minus 4. Don't forget that you're going to do it. Differentiate and substitute. Yeah, good, JamFam, good. Yeah, boy. Plus 10x plus 3ax squared. Okay. The gradient, this is the gradient, is 3 when x is 1. So for every x, I'm going to write 1. Now simplify this. Minus 4 plus 10, we can do that. 6 plus 3a squared. Oh. We can even do this. Minus 3 equals 3a squared. Oh, what am I doing? It's not a squared. It's just a. It was the 1 squared, right? Plus 3. No, I've differentiated it, right? Times power, take 1 off power. I've diffed it. I diffed it. I think that's right. Tell me if I'm still wrong. No, you're good. Thank you. Right. We're here, and minus 1 is a. So a is minus 1. Oh, that's what the question asked for. Good. A is minus 1. Double check our answers. A is minus 1. Good. Right. That's not too hard. That might have been. That's a merit. It's an easy merit. Yeah. Thanks, Spaghetti. Good. It's all good. What are this now? I've made heaps of mistakes. Alright, this is a cool question. It's gonna require explaining. Good. Let's do it. We've got half an hour before it's been 2 hours. Let's smash it. Right, a chemical slowly leaking on the floor. The chemical spreads out. Blah blah blah. Right, at a time t seconds after the chemical leaked. R is given by this. Is given by can be written with an equal sign. I don't know why they make your life hard. R is given by this. Okay. Let's have a look. Use calculus to find the rate of change of the area of the circle. If the area is A, the rate of change of the area is A dash. Okay, if the area is A, the rate of change of the area is A dash. Thanks, Duck Life. Cost me oh no, I got it for a present. This says with respect to time. So it needs to be a dash in terms of something t. Okay? And we want to add a specific point when the radius is 10. When the radius is 10. Right. Right now, we've got the area of a circle. That's a horrible looking A. My handwriting's getting pretty poor now. Pi r squared. We've got the area in terms of the radius. The area in terms of the radius. We want the area in terms of time, and then we can diff it. The cool thing is we've got the radius here. So instead of the radius, Ruddrafter, thank you. Instead of the radius, I can write everything that the radius is equal to, which is all of that there. And that's going to be squared. Now to square this, we can do the grid. 0.1 times 0.1. Ooh. 0.01. 0.2t. 0.2t. 4. I'm going to take some shortcuts because we are doing an E question. Okay, so this is our, this whole thing here with the square can be rewritten as this whole thing here. Right. The answers and questions don't link to the right stuff. They're actually they're set up for the probability one because I didn't realize we were doing calc. Let's get rid of all this. And now we can expand this pi if we really want. Now pi we just treat like a number that we know the actual, or we treat like a letter that we know the value of. Okay, don't stress about it. 2016 paper, Tim. Right. Now we've got A. We want a dash, remember? We want a dash. So let's differentiate this. A dash. We differentiate in terms of t. So we times it by 2, 0.02 pi t plus 0.4 pi, and that drops off. Good. Okay, we've got the rate of change with respect to time. Let's go bit by bit. We've got the rate of change with respect to time. Now we want it when the radius is 10. The radius is 0.1 t plus 2. When the radius is 10, the time is going to be 80, right? 80. So this is like helping us find, and we're going to sub that in for t. We type this all in, 0.02. I know the colors, dude. I'm so surprised no one else is like been as excited as I am about this. I'm like loving being able to use colors. This is 6.283. Okay, done. Fantastic. What I also know is that this is actually, look at this, 2 times pi is the same thing. 2 pi, we can just write it like that too. That's our answer. Now I know that's hard. I don't really have any ways to fix that. It is just a hard question. We've substituted in here. The colors might help with making the relationships. This is probably the hardest question here. And we're almost done, and we'll finish early. We'll do a little Q&A or whatever. Okay, exclamation form if you're ready to pack it in. Exclamation form, please fill in the form before you go. Right, the last question. Increasing or decreasing? It says decreasing. We get excited because we know how to do them. Actually, this is what I do. My automatic reaction is to double diff eventually and do some stuff with it. So, been given no other information, so let's differentiate this. 9x squared minus, this is funky. And right over here, 4a squared x. Calculator tomorrow. Not tomorrow, on Friday I'm doing probability. On Friday I'm doing probability. I'm not going to do algebra, sorry. In my course that I teach, I don't teach algebra, so I'm not probably the best person to do the algebra paper. I'm doing probability tomorrow. Let's look at this. 4a squared x, we're differentiating in terms of x. So just because the a is squared, it doesn't mean anything. This whole thing is a standalone chunk. And we differentiate it as if that whole thing was just some number. Kx. The derivative of kx is just k. So the derivative of 4a squared x is just 4a squared. So 4a squared, and the 5 drops off. Good, right? When we do this now, when we're looking at increasing, decreasing, we look at our fact turning point at f of x is 0. So we set this to 0. 9x squared minus 4a squared. Okay. Now we look at this and we think, oh goodness me, I can't solve this on my calculator because it's got an a in it. Right? So we can solve it by hand. Let's move this whole ugly piece to one side. So we've got 4a squared equals 9x squared. Divide by 9. 4a squared over 9. 6 squared. And the form it says algebra skills. Oh, man. Yeah, good call. I should fix that. I don't really calculus. I just copied it and then I forgot to change it. I was a bit busy today. Thanks for that, Dewey. Right, I think I fixed that. Cheers. Why are you diffing x instead of a? So we always are diffing in terms of x. We're always diffing in terms of x. Right? Yeah, we can do a Kahoot at the end. I've got one lined up. We're always diffing in terms of x. A is a variable. We're always diffing in terms of x. Now this is where it's going to start getting weird. 4a squared over 9. To get rid of the squared on the x will give us this. Right, now we've got this. So I'm going to make this left hand side look a little bit simpler. You can do the whole thing in terms of a would mean diffing a. Okay, see, I see what you're saying in the question. Right, we are in the question. It says Basically, x in terms of a means we are allowed to leave a in our answer. It means you will never find out what a is, so we want it left in the answer, something a. Right. But when we differentiate, we still focus on x. We still only care about x. We treat everything else as a number. Pi, a, k, 4, whatever it is. I hope that makes sense. Right. When we do this, you just need to know your third rules. Yeah, okay, plus or minus. Yeah, you're right. You're 100% right. Plus or minus for the square root. Good, man. Thank you. Right. That's actually important. Thank you. When we do our surds, now I don't know why they're called surds. When we do square roots and things like that, you square root the numbers and you can square root the letter. So the square root of 4 over 9. Let's have a look at it. Square root of 4 over 9 is 2/3. The square root of a squared I know is just going to be a. 2/3 a, or we can write it as 2a over 3. I'm going to write it as 2a over 3. So this whole thing here can be left as plus or minus 2a over 3 equals x. Right? So when we have a quadratic, normally we type this part into our calculator here. I'll use my actual laser pointer. This part into our calculator here, and we get given two answers, x is something, x is something. But because we solved it by hand, we get a plus or minus, and we still have those two answers. So let's look at our two answers. One of them is going to be positive 2a plus 3. Sorry, 2a over 3. One of them is going to be negative 2a over 3. When I get, let's use our cool straight lines. When we get our two options, we want to find out which is a max, which is a min, to find out where they're increasing and decreasing, so we can draw a picture. So let's double diff, y double dash. We've got y dash, y double dash is 18x minus, that all disappears. 4a squared all disappears. X equals this, x equals this. And y double dash equals 18x. I'm literally in the middle of a decreasing and increasing function. It's basically the same as a max and min. The whole process is the same, except this question's weird. I'm carrying on Dango. Right. So we've double diffed, and normally we sub in this value. If we sub this in, it's not really going to help us. Right? Let's sub it in. Y double dash equals 18 times 2a over 3. What's 18 times 2/3? 12. Dash equals 18 minus 2a over 3, which is going to be minus 12a. Okay, so this is where this line of information is important, where a is a positive number. If a is a positive number, it doesn't affect the sign of this. So 12a, if a is 900 or 1 or whatever positive number, let's say it's 5, no, let's make it easy, let's say it's 2, then this is going to be positive 24 and this is going to be negative 24. If a is 400, it's going to be positive some big number minus some big number. So we can treat it like this. Whatever a is, this whole thing, whatever a is, 12a is definitely going to be greater than 0. And whatever a is, minus 12a is definitely going to be less than 0. Now we look at Sunny Bill. He knocks these things over. Therefore, this one tilts to the right. That's a minimum. And therefore, this tilts to the left. That's a maximum. Okay, we've got more room to work on the right hand page. So we've got a max and a min at these 2 points. I'm going to write it. Oh, we don't have more. What? Where's our working space? Man. Let's go here and erase this. Right. So we've got, it's going to be annoying jumping around. So we've got a max and a min at these two values here. Let's write that down. Two a over 3 and x equals minus 2a over 3. This one was a min and this one was a max. Tell me if I'm wrong. A min at the positive and a max at the negative. A min at the positive, a max at the negative. Good. Okay. Now, from here, the question asks about increasing and decreasing. So, let's imagine we've got positive 2a over 3 and negative 2a over 3. This one is a max. So at this point here, we're going to draw a max. This one is a min. So at this point here, we're going to draw a minimum. Now they look really ugly, but we're going to connect them up with some lines and maybe even make it look a little bit prettier. Now, I don't know if it looks anything like that, but it'll do. We've got a min and a max. Okay, now the question asks for find the range of values where it is decreasing. What? I was not on that page. The range of values where it is decreasing. Okay, on this you can see that it is decreasing between this point here and this point here. So decreasing between x equals minus 2a over 3 and x equals positive 2a over 3. That's where it's decreasing. Now you could express that as minus 2a over 3 less than x less than, like that, if you really wanted. But also the sentence will suffice. This sentence here is fine. Now I know that's hard. Let's look at the marking scheme and see what they say. Right. The interval found. We found the interval. If we find x is this thing here, then we're good. Or if we just find the derivative, you get an achieve mark. The best way to pass is to try the harder questions by just differentiating and sub. Diff and sub, or diff and set to 0. If you dip and sub everything you see, or diff and set to 0 everything you see, you will probably pass the paper. If you can do the gradient of a tangent, y minus y1 equals m bracket x minus x1. Oh, I ran out of room. Okay, then you can definitely pass. Yeah, they have that one, so let's just make it not that. Right. Yeah, you're right. I think, well, yeah, it's more technically right to be like that. That's fine, fast tricks it. If you can't do the whole thing, that's honestly fine. Okay, if you try this one, you should be able to. Let's have a look. Go back. There's no reason why you can't differentiate that correctly if you're careful about that 4a squared x. If you just differentiate that, you get achieve marks. Right? Probably the same with this one. The one before that. Oh, that one's a bit different. But if you just differentiate and sub in this one, that's a merit. Differentiate and sub, differentiate and sub. Okay, that's the whole. Woo, I'm tired now. That's the whole 27. Let's put on some royalty-free music while we talk for the last bit. Nice. Now that's the whole 2017 paper. It looks beautiful with all the colors. Okay. I hope you guys found that helpful. Please share the word, get more people involved. The more people in the chat, the better the questions. So you read a question, won't know what's differentiate. Yeah. If you're in doubt, honestly, just differentiate. Right. Thanks so much for tuning in, guys. If you can complete the form, exclamation form would be awesome. If not, no worries. Exclamation form would be great. Give it a go. Fast tricks are just by tuning in, you'll probably got a higher chance of passing. Right? I've done a statistical analysis, and you do better if you tune in. Yeah, I mostly agree. The Kahoot. Yeah, let's find a Kahoot. I should have a Kahoot here somewhere. Oh no. How do I find my Kahoots? If you're in my class, you would have done this Kahoot. Kahoot, not .it. No, it's not sign up. Sign in. What's my... I'm on my personal computer, so I gotta log in properly. There's no... Oh, goodness me. Hold on. Oh, what's my username? It's like... Mr. T... I think. You put the masterpiece on... Ooh. Yo, I'm in. My Kahoots. Formsmith, thank you so much, Pip. Kickless refresher. Right. How hard do we want it? We're doing a calculus one, I'm assuming. What type of equation is it? Right. We'll just do some basic differentiation. Yeah, Reddit counts social media. I'm glad the Reddit post worked. Okay. I'm glad I can help you guys. The social media thing went off, but not as many people came and viewed as I was hoping. But hey, still happy if I can help one person, then it's probably worth it. Alright, let's play this one. Right, if you're still in the chat and you want to join this Kahoot. Oh, it sounds like it's going to be loud. Ah! 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 No. It's so loud. Oh. You can do Kahoot on computer. You can do it on computer. Sorry about the... Should we Kahoot music or royalty free music? Right. Now can I trust you guys to do the names okay? Let's put the Kahoot code on the screen. The Kahoot code is 8565855. free music. Free music? Let's turn it off. No, not that. Volume mixer. Turn it off. Royalty free, we can relax. Oh. Right, Kahoot to finish. We got some people. Let's go, let's go. Kahoot.it. Oh, let's go. Give me foods in here. Give me food. Is there? There must be. ONG 2002. Joshua isn't. Joshua's. Zabir. Right. Time to stomp some kids in Kahoot. Yo, let's go. Exclamation Fortnite. No Fortnite tonight, Kendrick. No, no, no. Thanks to all the followers tonight, team. Really, really appreciate it. We got heaps of new followers. Let's have a look. I read most of them out. Joshua Ant, thank you so much. Chill. Jeffrey from Kmart. I get a follow from Jeffrey from Kmart every single live stream. Jeffrey, you're doing something sneaky. Right? Real One Apple and Rough Drafter, thank you boys so much, or girls. Right. Alright, let's have a look. We got this going on here. Waiting for some more players. We got 35 viewers. We got 15 players. I'll give it sort of like 30 more seconds. We got Weird Flex. Should I join? I'm gonna join. Let's open it up. Let's go, let's go, let's go. Kahoot.it. Unfollow. You must do it every time, right? 856 5855. American. Asda. 856 5855. Yeah, man. Bobby by Jones, thank you so much. Nickname. Oh, almost spelled wrong. No. Right. National Maths is in. Right, you got 15 more seconds. I swear it's like a 10-second delay. Maybe even longer. Okay. I'm going to... Right, we're gonna go here. We're gonna start up, team. Oh, Bumbullet just made it in. Bumbullet, you've done this one before. Okay, are we ready? Oh, the 10-second delay. I'm definitely gonna win, right? It's unlucky for you guys. If I lose this. Oh, here we go. Oh, I was a bit slow. Alright, I just make it full screen? Yeah, I just make it full screen. Am I gonna be in the way on the thing? Oh, someone made a silly mistake. Just put me there. See if that helps. I've got to activate my windows. Right. Oh, look who's on top. Let's go. was a bit slow. Oh, team. The lag. My phone's dead. There's just excuses flying in. Team, what's happened? The questions. Oh, the questions try and trick you. This is too easy. I'm so far ahead. Stream delay looking mighty fine, dude. I'm loving it. I'm not even paying much attention. 12x. Oopsies. Oh, my phone turned off. Oh, I made a mistake. Oh, I see. Oh. I clicked this one because I didn't see the dash. Oh. Missed the dash, rip. Yo, I'm out. I'm out. No, no, no. Boom bullet. You're on top. Okay, okay. Come on, Kendrick. Okay, let's go. Ready? Good luck. I think I got this one. Yo, our viewer count has skyrocketed since we started playing Kahoot. What the hell? Ah! What? Oh, I'm stupid. Oh my gosh. I'm trying to rush, man. This is... I've plummeted. Boom bullet way on top. Ah, oh, man. Come on. Okay. Find the gradient. Boom. I worked it out by hand. Abused the power. Dude, I'm abusing the power by just... I'm trying to rush and get it real quick. Why is our viewer number so high? All of a sudden. What do we like on the you're gonna hear something real quick. Oh no, it's good. What do we like on the Oh, you got way more time for this one. I'm gonna skip it soon. We don't need all this time. What do we like on the science and technology like list, you know? Yo, we're number 3, boys and girls. We're number 3 team. We're 3rd best. Yo, too easy, too clean. I got that. Alright, I'm coming. I'm coming for you, Bumbula. I'm chasing you hard, dude. Grab the calculator. Inferior to the MCAT. Yeah, you're right, dude. You're right. Okay, let's go. Find the gradient. Whoa, I need a calculator. Oh, what am I doing? I think I got it. I was quite slow. I think one bullet might have beaten me. How'd you pass the kit? Circle undies. Yeah, dude, I love a good competition, man. This music's making me go hard. And let's get us yeah, we're the 3rd top. We're the 3rd top in science and technology. Yo, let's go. Let's go. Boom bullet. I'm slowly coming because I got this. Okay? I'm slowly coming. Let me clear my page. Right. Come on then. Oh, no calculator, easy peasy. Oh, we get it. Spaghetti, we get it. This is too easy. Mid flex. I want to flex on this all day, man. I want to flex on this all day. How many questions we got left? Can't be that many. Okay. I want to like skip the next one real fast. As soon as I answer, I want to skip it. Yo, I got it right. Answer streak going up. What? How's it? Bumbula is making it come. I'm gonna kick you, dude. I'm just gonna kick him. It's not something you'll teach it, dude. It's definitely the same. This is the last question. Oh, I could have done it quicker. Yo, I will do. I do what I gotta do to win. This is my stream. We got 12 answers. Is that how many we got before? Oh no, I got it wrong. I think. I hope you did. If I get the big comeback, I think you got it wrong, Spaghetti. Bumbula is dropped. Here we go. Too easy. Let's look at the winners. Let's look at the winners. Ooh. Oh. Oh. I just got one thing to say. Dude. Oh. Oh. Ooh. 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 That's what I think about your stream delay complaints, man. Oh, Bomb Bullet 1. Bomb Bullet is not number 1. Thanks for the follows, team. Okay. It's 9:11. If we... It's 10 past 9. If you got any more maths questions or anything like that, that was a fun way to end. I'll try to create a Kahoot to finish the probability off. That's a good way to finish. There's a couple people just joining us. Sorry, but I'm out of here. Fortnite right now. Maybe tomorrow. Maybe tomorrow we'll play some Fortnite. I haven't really played much of the new patch. Thanks so much for watching. Hopefully it helped. Just look at all the work we did. Look at this. This is all you guys. These two pages look especially nice. Kiwi Rod, Rusty Sky, I got no idea who you are. Sorry dude. Can't just jump and be a mod. Thanks for tuning in. You guys are the MVPs for tuning in. Thank you so much. Good luck for your exams. Study some more calc. Excuse my leg. Okay, I will see you on Friday. Tell everyone. No, I haven't done proper earlier, Kali. Okay. Exclamation form. Thank you. What is this now? Exclamation form. Exclamation form. Complete the form, please, please, please. I'm doing it on Friday. See you on Friday. Friday, Friday, Friday. Let's go. Oh, let's even go like this. Let's make it a thick pen. Friday. Prob. I've got way. My probability should be way more on point because I actually thought it was today, so I prepared for it way more. Okay, Friday we're doing probability. Tune in, enjoy. Friday 7 p.m. always 7 p.m. The form isn't even loading for you. It should be working. I don't know why it keeps kicking you, dude. Unban. Sorry, dude. So nice colors. Very exciting. Thank you for watching. If there's no last maths questions, I'm gonna go. I've got friends to have a chat to. Whoa. Alright, thanks for watching. Hope you enjoyed. I'll leave you with some music for a bit. But thanks so much for watching. Oh, special shout out to the people that were here from the start. Who was here? What of this now? You are awesome. Thank you so much. Danjo, Lord, you've been here for ages. Spaghetti, you've been here a while. You're always here, Spaghetti. Dewey, I think he's still floating around. Dewey should still be here. Yeah, Dewey's still here. Latanium, you came quite late, so no shout out for you. Pit Mum's been here the whole time. Awesome. All the people that chatted. Sug Life's been here for a while. The Exponik, it's been here ages. Big Hooter, it's been here ages. Thanks for tuning in. Thanks for being here a long time. I'm out. Enjoy. Is it Danjo? What is it? Dango. Dan. Go. I don't know, man. Right. Enjoy. See you later. Thanks for watching.